Hello, so I wanted to do a video today on finding the volume of a sphere. This is quite a tricky topic, much more likely to be in a higher paper. So these are the four types of questions that I will go over. So if you're working on anything that looks anything like any of these questions, then you can work through the example with me. So in order to do this work on finding the volume of a sphere, like I say, it's quite a tricky topic. So you need to be comfortable with these areas. So substituting values into a formula, using indices or powers, finding the volume of a prism, a 3D shape with the same 2D cross section all the way through, and that includes working backwards to find missing lengths. It's quite useful to be able to find the area of a circle, and also changing the subject of a formula. The last two or three are really going to be handy with the third and fourth example that I'm going to go through. So to start with, you could be given a sphere. Now, the same rules apply to this as with just a regular 2D circle. You need to remember that if you have the diameter and the radius, or if you need one or the other, and you're given one, you need to remember how to get from one to the other. So remember, the diameter is from one point on a circle, or in this case on the surface of a sphere. It must go through the center and it goes all the way to the other side. The radius is always half of that. The radius goes from the center to the surface of the sphere. So if I give you the radius, you want the diameter, you double it. If you get given the diameter and you want the radius, you half it. Okay. So here's your sphere. You need to know the formula. The volume of a sphere is equal to 4 pi r cubed all over 3. Now, the important thing you need to spot here is that you need the radius, and then we're just going to substitute that value in. So to find the volume of a sphere, we're going to do 4, this means times pi, and then multiplied by my radius. So this here goes from the center to a point on the surface, so that is my radius. Always check to see if you're given the radius or the diameter. So it's that value we're going to use, 12 cubed, all divided by 3. And then it's just a case of putting those values into your calculator. So I'm going to suggest you use the fraction button, and we're just going to write 4 times pi times 12 to the power of 3, and then in the denominator of the fraction we're going to write 3, press equals. It is always a good idea to write 2304 pi. This here is in terms of pi, and that's an exact answer in terms of pi. You must also remember that your units, meters, in this case are going to be cubed because it's volume. Now that 2304 pi, it's always, like I say, worth leaving it written like that, because with the more tricky questions, sometimes you'll be able to cancel things out, and it makes your final answer more exact. However, if the question said something along the lines of give it to 3 significant figures, or 1 decimal place, I'm going to do it to 1 decimal place. What we can then do is, in my calculator, I'm going to press S to D. I'm going to do that to 1 decimal place, so that's 7238.2. 7238.2. Remember your units, meters cubed. That's it for the first example. The second one, this time we are given the volume of the sphere in the question. We're told that the volume of the sphere is 34 centimeters cubed, and we're asked to find the diameter. So this is where it's really useful to be able to kind of change the subject or rearrange a formula. Watch out for these questions. We are going to start with the formula for the volume of a sphere. So I know that the volume is equal to 4 pi r cubed over 3. Now you'll notice in the formula we are working with the radius. So when I'm going to use this formula to work out the radius, and that's going to give me the length from the center of the sphere to the surface. What I can then do at the end is double it to find the diameter, but we have to work with this formula. So in this case, I'm told that 34, that's my volume here, is equal to 4 times pi times r cubed, all divided by 3. Now what I want to do is I want to make r the subject. So this is why it's really important to be able to change the subject of a formula. So the last thing I did over here was I divided by 3. If I was working forwards, the last thing you do is divided by 3. So I'm going to multiply both sides of this equation by 3 to undo that dividing by 3. It's the inverse of dividing by 3. So if I do 34 multiplied by 3, that's going to give me 102, is equal to 4 times pi times r cubed. Now, it's these two bits here that are stopping me from just having r cubed on the right hand side of the equation. So what I'm going to do is I'm going to divide both sides by 4 pi. And if I do that, I get 102 divided by 4 pi is equal to r cubed. Notice I haven't used my calculator yet. I'm just moving things around so that I only have to put one calculation in my calculator. So now if the radius cubed is equal to 102 over 4 pi, I'm actually going to cubed root both sides of this equation. So I'm going to cubed root the whole thing. And when I come to use my calculator here, I'm going to use the cubed root button, which is above the square root button. So you need to press Shift and then that one there. Now inside the fraction, inside the cube root, I'm going to put the fraction button, and then I'm just going to write 102, and I'm going to divide that by 4 pi, go to the end and then press equals. Oh, I should have written equals r. And then I'm just going to switch these things around. So r is equal to 2.00, and then check the units, that was centimeters. We've now found the radius, so I know that this length here was 2 centimeters. Remember, the question is asking me to find the diameter. So if the radius is 2 centimeters, we're going to multiply that by 2. So x is equal to 4 centimeters. And that's your final answer. Okay, 2 more examples, getting slightly more tricky. Okay, so here I've got, we're told in the question that a sphere fits exactly inside a cube. That means that the faces of the cube touch the sphere at one point. So every face of the cube is in contact with a part of the surface of the sphere. And we're being asked to find the empty space that is left around the sphere. So in order to do this, if you were to work out the volume of the cube and the volume of the sphere separately, we are then going to do the volume of the cube take away the volume of the sphere, because that was going to tell us what the space is left around it. So I'm going to start by finding the volume of the cube. So the volume of the cube is going to be base times width times height. Now, because it's a cube, all of these lengths, oh, that's millimeters, are 6 millimeters. So the volume of this cube is just 6 times 6 times 6. And if I did that in my calculator, that gives me 216 millimeters cubed. 216 millimeters cubed. Then I'm going to find the volume of the sphere. Be careful here, because this 6 millimeters would be the diameter of this sphere. Because remember, the top and bottom of that sphere touch the top and bottom face of the cube. So I want the radius, because I'm using the formula 4 pi r cubed over 3. So the radius of this sphere is going to be 3 millimeters. So I'm just going to put this into the formula. 4 times pi times 3 cubed all over 3. And then I'm going to use the calculator to do 4 multiplied by pi multiplied by 3 to the power of 3. And then I'm going to put 3 at the bottom and press equals. Again, this is more exact, 36 pi millimeters cubed. So now that I have the volume of the sphere and I've got the volume of the cube here, the empty space is simply going to be the volume of the cube subtract the volume of the sphere. And the volume of the cube is 216 millimeters cubed, and we're going to take away from that 36 pi. So just go back to my calculator. 216 take away 36 pi, press equals. Now this is our final answer, so you can now round. It's always a good idea to avoid rounding calculations until the very end, because otherwise your final answer loses accuracy. So to one decimal place, 102.9, 102.9, and then the units were millimeters cubed. So this blue space inside the cube but outside the sphere, that has a total of 102.9 millimeters cubed. Okay, last example. Now this is typical of a kind of applied exam question. These are really, really tricky. So we are given a cylinder over here, and that cylinder has some water in it. And the height of that water inside the cylinder goes up to 16 centimeters, but the height of the whole cylinder is 25 centimeters. And we're given the diameter of the cylinder. We're also given a little sphere. This is not to scale, so even though the measurements don't look as though they're right, that's what that means if you ever see that in an exam. So we're given the diameter of the sphere and the diameter of the cylinder. If I were to drop that sphere into the cylinder, that cylinder would displace some of the water, and the water level inside the cylinder would rise. The amount that water rises is equal to the water that has been displaced by the sphere. So, and that water that's been displaced would be equal to the volume of the sphere. So the first thing I'm going to do here is to find the volume of the sphere. And that's just a case of volume equals 4 times pi times radius cubed all over 3. Even if you didn't know what to do in a question like this in an exam, if you just do something that you know how to do, chances are you're going to pick up some of the marks, if not all of them, because this would be a 4 or 5 marker. Okay, so let's find the volume of this sphere. The volume is equal to 4 times, remember this 18 is the diameter of the sphere, so the radius is going to be 9 centimeters. So we're doing 4 times pi times 9 cubed all over 3. If I were to put this into my calculator, I'm doing fraction 4 times pi times 9 cubed, and then I'm going to divide that by 3, press equals 972 pi. Do not round this at the minute, leave it in, because remember this is exact. Okay, so that's going to be centimeters cubed. That's the volume of the sphere. Now, we are asked to find the increase in the water level. Let's do this bit in a different colour. The increase in the water level. So, when I put that sphere in, this isn't drawn accurately of course, that water level is going to rise. That gives me an extra little cylinder of water on top of the water that's already there. So this length here is just going to represent this bit on top of the 16. We don't know what that height is. That would be equal to the increase in the water level. So I'm just going to call this h for height. Now, because that water, that extra water that we get from putting the sphere in, is in the same cylinder, that water will take the shape of the cylinder it goes into. So the diameter of this new cylinder is going to be equal to the diameter of the big cylinder that contains all the water. So that is going to be 23 centimeters, the same as this. However, remember, if I am working with, because we're going to have to find the height of this. So remember, the volume of a cylinder is equal to pi r squared multiplied by h, because a cylinder is just a prism, the circle is the cross section, and then we just multiply that by the height. So that's the area of the circle, then we multiply it by the height. Okay, we don't know h, that's what we're trying to find. We do know that, remember, that volume of the sphere will be equal to the water that's displaced, and therefore that volume of the sphere is also going to be equal to the volume of this new cylinder. So I know that 972 pi is equal to pi multiplied by the radius squared, which in this case is 11.5. That's half of 23. So multiplied by 11.5 squared, and then multiplying that by the height. Now remember, I said at the start it's sometimes useful to leave everything in terms of pi. This is an example of where that might come in handy. Both sides of this equation, we're just multiplying. The left-hand side means 972 times pi, and then we're just timesing everything on the right-hand side. Because we are timesing everything, and there's no adding or subtracting there, we can actually divide both sides through by pi. And if I do that, we can just cancel these things out. So I get 972 is equal to 11.5 squared multiplied by the height. Now I want to make h the subject of that formula, because then I can find out the height of this new cylinder. So I'm now going to divide both sides by 11.5 squared, I should have put. So 972 divided by 11.5 squared is going to give me my height. And then if I just finish off the question here, 972 divided by 11.5 squared, press equals because this is my final answer, I'm now just going to turn that into a decimal. So h is equal to 7.35, and it was centimeters. Because this is just height, it's not a volume or an area, the units are not squared and they're not cubed. So what this is telling me is that the length here is 0.35 centimeters. Therefore, the increase, the extra water in the increase in the height, that height is increased from 16 up 7.35. So the increase is 7.35. That's not the total depth of the water. That's just this little, the height of this blue cylinder on top. Okay, so just to show you the question generator that I've made for this topic, each of the 4 questions on here correspond to each of the examples that I have just done. We only looked at spheres in this video, but you can also, when you get a bit more confident, try only for types 1 and 2, where I give you a hemisphere and you have to find the volume or work backwards using the volume to find the radius or diameter. And you can get all different types of questions individually, or you can get increasing difficulty. And once you've got the hang of all of them, you can try a mixture where I don't tell you what type of question it is, and that's really good practice in preparing yourself for kind of exams. You can also make it so that some of the radii, I should say, and diameters of the spheres and hemispheres are decimals. That will make it really challenging. Just finally, I'll put this file in the description to the video so you can download it and get some practice. When you open it, you will need to click enable content or enable macros, I think it is, in a yellow ribbon that appears at the top. That's it. Thanks very much for watching. I hope it's useful. Bye bye.